Okay, let's see how this works out. I'm trying to use a few different things here, so I'm hoping it'll all work out alright. How are you all? This is officially lecture 4, if you like. And I just wanted to take you through a bit about the actual use of data and some of the terms involved in statistics. So, well, the first term I wanted to talk about is this one here, the population. So the population is often used in a technical way. For instance, it could be all the workers. It could be all people who are workers, basically. It could be all management, just looking at the population of management and nothing else. It could be all people in Australia, all people in the UK, all people in the world. And it excludes animals, obviously, although some people may in fact fit that category. But anyway, well, look, it could be you know, each time you set a population, you've got parameters there which exclude some people and include others, or things. Could be things as well, of course. Could be all those people employed in this particular industry, or it could be, and this is a much more likely one for you, I think, is that it's going to be all people employed by your organisation that you're going to be collecting data on. Although, of course, you will be looking at other data, and so you need to always look to see what the population is for any statistical understanding. You've got to know the population. If you don't know what it is you're looking at, then obviously you can't say anything sensible about it. Now there's widely considered two different types of statistics. There's descriptive statistics, which aim to summarise a data set. In other words, you've got a data set being a bunch of variables with data collected about them, and that data itself can split into two different ways. You probably hear about different types of data, like you can do counting type data, where you're counting the number of things that happen. So if it's an injury, you know, if it's something which can be reduced to numbers, then it makes it a lot easier. But there's also well, that's normally called quantitative statistics, where you're looking at a particular quantity, something which is simply measured as, you know, by a number. And there's also, of course, qualitative things as well, which is about the quality of something. It could be quite often you find surveys using qualitative and quantitative data. So they'll ask you for instance, a qualitative data would be, what's your age? You know, how much do you earn? How many people live in your house? How tall are you? How short are you? What ethnic background do you have? Blah blah blah. No, these are generally something which it's not a hard and fast rule as to what it is and isn't, and it doesn't really matter giving it a name. It's not that important. But in the same data, same survey, you might find somebody trying to get some qualitative data, you know, which could be something like, you know, what's the quality of something? And it's a very difficult one, I reckon, to break down. And it's largely up to, you know, what you feel like as to what you call it, in a sense. But I see qualitative data as being information like, you know, how much do you enjoy going to work? You know, it's difficult. What do you mean? I enjoy going to work 7. You know, whereas how many children have you got? 3. That's easy enough. Are they well behaved? You know. You know, what sort of level of behaviour are they? Are they well behaved, or are they badly behaved? Or you can turn a qualitative into a quantitative by using pardon me, bits of by converting it into bits of data, so you can say that something, one particular quality equals 1 and another equals 2, and you can do it that way. But look, we won't go into that too much at the moment because it's not really as important as this other distinction, which is the distinction of inferential statistics. Now, they are, as they say, it's about inferring something. The difference with inferential statistics and descriptive stats is that in inferential stats, you're generally measuring a sample of a population rather than the whole population. If you've got well, a lot of times, for instance, polling, if you take something like political polling, they can't go out and measure every single person who's going to vote that day and ask them what they're going to vote. It would be far too complex a thing to do and costly. So they do an inferential measure by measuring a sample of the population, which I hope is a representative sample, and that's why it's a very inexact science, if you like, because the type of population collection and so forth is very subject to a lot of subject to theories, and those theories are not necessarily true or don't hold tight necessarily for every area that they're looking at. But anyway, you get the idea. Inferential stats, you're trying to infer something from about a whole population from something which isn't the whole population. So descriptive stats are much more, they're much more down, they're kind of in our field of workplace health and safety. Descriptive stats are more likely to be available than inferential stats. Inferential stats by their nature are not as competent, and so you put a lot of there's a lot of hard work with inferential statistics, and it's not something that I would like you to spend a lot of time on. The reason being that you get extremely tied up in the jargon, and there's a lot of argument that goes on about what constitutes the sample, a proper sample of a population, and how you'd measure that. When most of the time really we're dealing with statistics that are quite straightforward as to what the population is, and you can measure the whole population. You can measure the whole population of people who have made a claim on work cover. That's the statistics are there for that. There may be some differences in legislation for claiming on work cover which would cause problems, but nevertheless it would still be a descriptive stat. If you measured just 4 representative clerical, I suppose you could actually do that. You could say, I want to look at people in clerical positions, but there are a number of different types of clerical positions. So what I want to do is to take a representative sample of 4 types of clerical positions to give some understanding of what that might be like, rather than say measure all clerks who are grade 1 clerks in a public service, so as opposed to those people who are grade 7 clerks or whatever. I don't know whether that still works or not. It certainly was in my day. Okay, so let's have a look at a data set. Here's a data set. Here we've got employees with paid leave entitlements. I hope you can see all of that. Let me just move it into the screen a bit. Now, I was going to actually do this because I thought, hey, this is bloody interesting. Employed. This is coming from the Australian Bureau of Stats, and it shows you the variables. The variables I put in a different colour. So you've got the years going along here. I'll highlight those so you can see them. There's the years going along there, so 94 to 2001, and you've also got the industry down the left hand side here, the y-axis. Now that's all kind of interesting. I mean, it'd be nice to see, wouldn't it, I wonder what paid leave entitlements you know, whether they're the same in all industries. I mean, you know, that could have some bearing on what goes on. Who knows? It'd just be interesting to have a look. But the problem with it is that what they've got is that it's done per thousand. So each one of these figures is not per thousand. Sorry, it's done in thousands. It's a raw number. It's simply, if you look at it, you see agriculture and forestry and fishing. There were 56,000 people, males, who had paid leave entitlements. Now, in order to make sense of that in comparison to all of these other figures, we'd have to know what the total number of people are in each industry. And from that, then we could turn it into a percentage, and then we could look at it sensibly, comparing the two of them. You know, we could say that manufacturing industry has a higher paid leave entitlement for males than agriculture does. But with these raw stats, we can't actually do that, because we're missing one of the most important things, which is a comparative figure for us to look at to say that, you know, it may be, although there's 668,000, so just over 500,000 people in manufacturing in 1994 had paid leave entitlements, and that has gone down by 2001. Did it go down relative to the population of people in manufacturing? So if you see this shift in numbers going down here, which it actually goes up in 95, and then quite a big jolt down in 96. What's that? You know, what did that come from? So you can get some interesting trends out of it, but you can't really get a trend that operates between all of the industries themselves. So you can't go this way with the data. You can go across with one data, but you literally just can't go the opposite way. So instead of doing that, I've decided to go to a different data set, and this will be you can find this PowerPoint in I think I'll put it up as a PDF so you can all get to it easily and understand it. All of the stuff I use, by the way, is on a Mac, so if you're on a Mac, then you'll see all of this. You'll know what it is. I'm using the program called Numbers and another one called Keynote. Now, they all export out to PC versions so that you can use them without any problems. I just don't have the money to be able to go and buy myself a set of PC version, you know, for Excel, for instance. I'll check with the unis if I can get a copy from them, but at the moment it's difficult for me to do. But they do. We're not going to be going into such great detail as to how you use an Excel spreadsheet that's different from the Mac version. The Mac version's pretty much the same. They all have the same things. You just need to look and have a bit of a play around, and you'll find it all right. Okay, so look at this. We're looking at costs in millions of dollars of work-related injury and illness by cause of injury or illness. This is the 2008-9 year, right? So now there's some, and part of the reason I'm showing you this is because I want to show you a little bit about the, you know, the concepts and words in data, but also you can pick up, you know, what's the failing in it? What would you like to have? What information would you like to have? I really want to sensitize you to this notion of looking for new variables to help you understand the variables that you may have recorded in your workplace or industry, but you need something more than just what's recorded. You need to explain it. It needs to be explained better. So 2008-9, is that the financial year, or is that 2 years run into one, you know, into a data set? And you'd need to be able to figure that out, which you probably could do from a report, but I didn't look. Anyway, then we've got, of course, a bunch of variables here. We've got these variables here, which go down to here, and these are falls, trips, and slips of a person, hitting objects, being hit by objects, sound and pressure, body stressing, heat, radiation and electricity, chemicals and other substances, biological factors, mental stress, and other and unspecified mechanisms. Now, what's the first thing you see when you see this data is that you've got to be able to understand what these mechanisms are to make any real sense out of them. Falls, trips and slips are probably the most obvious ones. Hitting objects, I'm not sure what the hell that means. Being hit by objects, that kind of makes more sense to me. Sound and pressure, I'd like to know a lot more about that. Body stressing, that's fairly straightforward, I suppose. Heat and radiation and electricity, there's three put together and I'm not sure that they really belong together. It would depend on what industry you're looking at. Chemicals and other substances, probably that's pretty straightforward, but when you look at it, you look at it and it goes, there's 600, this is cost billions of dollars, so there's another whole question that comes up about costs of millions of dollars. So how did they actually allocate the costs? Was, you know, how did they measure that? What's the measurement of the cost in millions of dollars? There is some talk of that in the report, but I didn't understand it. And disease, that's kind of interesting, isn't it? Chemicals and other substances cause disease at a rate almost double the rate of injury. So how are they defining disease in comparison to injury? So that's obviously very important. All of the bits in this data set, which are variables, anything that varies, that's a piece of data that varies from the other data. In other words, it's been put in its own little set. All of these require very clear definition for them to be useful or interesting in any way. If they're not really well documented and understood, then it makes it very difficult to use the data for any inferential purpose, if you like. If you want to infer something, if you want to look at it and say, and here's a sort of inferential thing. Now imagine that I've just taken a job as the health and safety person for a big mining company. And I get this data, I find this data, and I think, okay, that's good. This can tell me something about what are the things that we do, what are they likely to cost in dollars in relationship to the operation of my business. If this is a set of data that comes out of the whole of Australia, which I think it does, in that case, then what is going to be the most costly in terms of me looking at things? I should look at the most costly or the most likely to happen, if you like. And in order to do that, I need to look at the figures in some greater detail than I'm looking at them at the moment. I'll show you how we do that in terms of comparing them. But you can see straight away there are some things like body stressing, 10,000. So it's 10 in terms of $1 million. That's $10 billion. That we're to $10.9 million. So that's 10 billion. 10.9 billion, isn't it? 9 with 3 zeros after it in terms of millions. 6 zeros after it. Okay, so whatever. We're looking at it from the point of view of each one of these and trying to get an idea of how they work. And with these, what we're going to do is do a couple of basic mathematical understandings. There are two further statistical terms, if you like, which I'd like to just bring in here before we do that, and that is the statistical terms of graphic statistics and what are known as summary statistics. Now, in graphic statistics, all we're doing is we're saying is that we're laying things out in a graphic form for you to see a picture of it. Okay. In the summary statistics, what we do is we take the detailed statistics that we've got here, right, and we actually summarize those in such a way that we don't talk about we talk about all injury over a period of this year of 2008-9, or we could talk about all diseases. We could talk about what the totals are of that whole lot. We could look at the percentage of costs. We could say, what is the percentage cost of, in fact some of it's already here, you know, falls, slips to a person, 14%. The cost amounts to 14% of the total cost of injury and illness, injury and disease over the time, which is pretty big, right? Well, reasonably big, but the big one, 41% for body stressing. So, you know, obviously that's a very costly thing. That's, I think, bad backs, stress, and doesn't look like it includes mental stress, because mental stress is already a variable. So body stressing sounds like it's sort of lifting, straining, backs, musculoskeletal kind of problematic things that result from stress, not as a result of being hit by an object or hitting an object. Okay, which is, I can't quite get my head around this difference between hitting objects and being hit by an object. I suppose if I ran into something, that would mean me being hitting an object. If I hit by an object, something runs into me, and that makes sense, except for the fact that I'm not sure why I would want to differentiate between the two. However, they have, so we've got that data. Right, so go back again to this. So the summary statistics have a number of little things that they whack on here. Here's a few of them. The average or mean of which you've come across 1,000 times, I'm sure. People will say on average, you know, people are, Australian men on average have an average height of 175 centimetres. Say that's what it was, right? That makes sense. That it simply means it's the mean or average is a set of data values, is the sum of all the data values divided by the number of data values. So in this case, and we'll show you what that is, it's the set of all data values. So if you wanted to take the average of this, of all of the injuries, what's the average cost of an injury? You could take all of these guys here, make a sum of them, and then you would divide them by the number that you've got on the left hand side here, which is 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we've got 10. So it's whatever the total of this is divided by 10 will give you the average, and I'll do that in a minute so you can see it happening. Go back to the other one. The median is the middle value of the data set when it's been arranged in ascending order. I'll show you that. That's kind of useful in some circumstances. The mode is the most common value. So these are things you'll come across and when people talk about data, and you need to have a bit of an understanding of what it is. I'll show you all of these, right? The range is simply the highest and the lowest. So, you know, if you'd say the range of heights of the male population in Australia, you know, range from the lowest, which would be a person with dwarfism, might be, I don't know, say 100 centimetres to the highest, which would be maybe 220 centimetres. That would simply be the lowest and the highest, would give you the range of height. And that could be useful for, you know, if you want to make doors that you know everybody can get through. You need to know the range.